everyone, and welcome to today's webinar, Accelerating Commercialization with Custom OEM Solutions and GMP. I am Kaylee Bach, and I'll be your moderator for today's event, which is presented by LabRoots. Today's educational web seminar is brought to you by Cytiva and Integrated DNA Technologies. To learn more, please visit cytivalifesciences.com and idtdna.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. This webinar is educational and thus offers free continuing education credits. Please click on the Continuing Education window at the bottom of your screen to obtain your credits. I'd like to now welcome our speakers. Matthew Davies, Custom Service Leader at Cytiva, Amy Webster, Custom Projects Leader at Cytiva, Mitch Gore, Innovation Product Manager, PCR and Core Oligos at IDT, and Renee Rathjen, Commercial Product Manager, PCR and Core Oligos at IDT. Matthew, Amy, Mitch, and Renee, you may now begin your presentation.
Thank you very much. So, quick agenda of what we're going to cover today. So, and the first part is going to be the Cytiva's Customized Solutions team, what we do, who we are, and then going into detail about one of our services, which we call the lyostable, so freeze drying, what we do, why we do it, how we do it. What our capabilities are, both on the R&D scale and in the manufacturing scale, and how we would take your product from small-scale R&D into full-blown manufacture. We'll then pass over to Mitch and Renee at IDT, and they will take you through the history and capabilities of IDT, both in their GMP and 13485 capabilities, and also their large-scale capabilities, and what they can do for your custom formulations and your custom kits. So starting off with Cytiva's Customized Solutions team, we're a team of scientists that are dedicated to helping you solve your problems. We're roughly split into 5 different services. The lyophilization or lyostable service, which we will be going through in more detail today. We also have custom biology, so our catalog products, we can create a custom version for yourselves with your custom pack size or slightly different components if needed. Our Ceramag and beads we can customize. We can do differences of concentration, formulation, pack sizes, but we can also conjugate IDT oligos to it, antibodies, things like that. Contract manufacturing, if you have buffers that you need to make and pack into your own label tubes, something we can do. And our 96-well filter plates, we can put in a custom membrane for you as well. So it takes a couple of minutes to go through lyophilization and our lyostable service. So lyophilization or freeze drying is the process where we solidify and stabilize an assay, enzyme, RNA, reagent by first freezing it and then by dehydrating it and removing the water. So how we do this is we take it down below its triple point, so below the point at which, below the triple point, a mix will go from a solid state straight to a gas state. So in the freeze drying process, the ice is sublimed straight into a gas. This is then removed from the product by being caught in the condenser. This leaves us with a really dry cake, and the structure of the cake allows it to reconstitute really simply upon addition of the sample when we run the assay. To do this, we also need to add protectants, so particularly enzymes. They don't like being frozen and they don't like being dehydrated. So we have a range of proprietary excipients that we will add to your reagents to protect them during this process. So how we lyophilize, we have your bespoke reagents. We have reagents from IDTs like oligos, enzymes, things like that. We then combine both of them together and formulate them and add our proprietary excipient mix to stabilize and protect all the reagents. We then have two options. We can dispense them and then lyophilize them, and this is our cake format, or we can turn them into beads, lyophilize them, and then dispense them, and that is what we call bead format. With both of them, we can use tubes or custom plasticware that you require for your assay. So this slide shows results from a quantitative research study that was commissioned by Cytiva last year, highlighting both the reasons why we lyophilize and also for a lyophilize assay, what are the critical parts of it. For example, if you're talking a point of care diagnostic test, you want to be able to store it for long-term at ambient conditions. This allows you to ship at ambient and also store at ambient, saving both money and reducing carbon emissions. But what we also need is for this to have comparable activity to the benchtop assay. So this is something that Cytiva can work with you to develop so that we have the long-term storage and reliability that we need in an assay. Okay, so the types of assays that we can do this with, or we have done this with, we've done LAMP assays, we've done multiplex qPCR and also RT-PCR assays. We've done enzymes on their own, we've done RNA and DNA on their own. We have a range of Simplify and Genomify kits that we have both catalogue versions and also custom versions that we can do. And the magnetic beads we can conjugate, and we can also lyophilize those as well. Now, going through a bit more as to Cytiva and where we are and what our capabilities are. So we have a global presence. We have modality teams all around the world that are an initial point of contact. They are in direct contact with ourselves. Our main R&D facility is in Cardiff in the UK, and our manufacturing line is also here. So for our dedicated R&D line, we have 2 pilot scale freeze dryers, 1 small scale R&D freeze dryer. We have 2 enclosures for packing the lyophilized product in. One is a dry air enclosure, the other is a nitrogen. And we also have several different QC equipment. So we have a glass transition temperature machine, so that gives us an indication of how stable your product is. We also have a KF to determine the moisture content of your product. We also have both a freeze drying microscope and a standard microscope enabled to visualize what is going on with the product. Along with this, we also have a small lab in Shanghai where we have a R&D freeze dryer, we have packing equipment, and we also have TG and KF QC equipment. As mentioned, our manufacturing centre is also in Cardiff. Again, we have a separate dedicated manufacturing team and a separate dedicated manufacturing laboratory. We can manufacture various different batch sizes from about 5,000 cakes up to 300,000 beads per run. To do this, we have 4 different freeze dryers. 1 batch would go in each freeze dryer. We have various different automated liquid dispensing, both automated and semi-automated. Manufacturing, again, have their own nitrogen enclosures and dry air enclosures for packing the lyophilized product. So you can imagine we've just spent a while removing all the water from it. The last thing we want to do is expose it to humid conditions and it pick that water back up. So we package them in protective environments. Once it's then packaged, we will then pouch it and put labels on, and the labels we can use and have all the customer logos on. And then they can be then boxed in whatever boxes is needed. For each manufacturing batch, we can also run quality control, so we can confirm the TG and KF of it. And all of this is run in our Cardiff facility, which is 13485. So going through the process of how we go from initial contact all the way through to a manufacture process. So initially, the modality team, your local modality team, and our team will have a call. We'll talk through your project, your problems, what we can do, and what we think the final solution will be. We'll then agree on some small-scale R&D runs called proof of principle runs in order to test this out. And depending on the results of the first run, we then repeat and plan some more. Once both yourselves and us are happy with the product and the process that we have developed, we will then lock it down and we will then look to transfer it into manufacture. Now, the first thing we would do at this point is agree with yourselves what steps we want to take, what bits of the process we want to validate, and then I would present it to our internal stakeholders. So we've got customer service leader, we have manufacturing lead, we've got a QA lead, and we've got our technical support lead. I would present to them what we've done so far, what we want to do to transfer this into manufacture and confirm the last bits, and we'll get their buy-in. All of this will be captured in a design transfer plan that would be agreed both internally and also with yourselves, and then the plan would be executed. Once the plan's been executed and we've confirmed the results, you've tested the activity and you're happy with it, we would then write a report and fully set this product up in our system. From that point on, you'd be able to order this as if it was a standard catalog product. So during this development, you'll be working directly with us with the support of our modality team. We would design and transfer and manufacture this product to your specifications, your packaging, your design. We also have raw materials that we can store on site, and we recommend that these are drop shipped to us. So customers, suppliers like IDT, you can order directly from IDT and they will ship to Cardiff. So at this point, I'd like to hand over to Mitch and he can tell me more about IDT's capabilities.
All right, well, thank you, Amy. Yeah, my name is Mitch Gore. I'm the Innovation Product Manager, one of them for our core products, which is qPCR and Custom Oligos. So just as by way of overview, just wanted to let you know that IDT began commercial oligonucleotide synthesis in the late 1980s and has grown to become a worldwide leader with over 95,000 individual sequences produced on an average day. Now, key to this growth was the development of the proprietary and customized synthesis and processing equipment that we have, as well as workflows and the development of some innovative technologies for genomics applications. Our customers are widely distributed across academia in molecular research, synthetic biology, and pharmaceutical research and development. Now, the heart of IDT, of course, is the oligonucleotide synthesis, and the fidelity of this process has really been the key to IDT's success. Now, being able to optimize the coupling efficiency of the synthesis process allows for us to maximize the full-length yield, as well as have improved outcomes after downstream processing. So our main facility in Coralville is where most of our work happens, but we also have manufacturing sites in San Diego, California, Research Triangle Park in North Carolina, Leuven, Belgium, and in Singapore. And we also have a satellite R&D facility in Redwood, California. Now, as we discussed earlier, a key to the success of IDT is the ability to control coupling efficiency via the development of proprietary synthesis equipment and processes. Now, another key is the optimization of the other aspects of the business, such as raw material sourcing and QC, custom software to support our LIMS systems, establishment of customer care groups specialized to the needs of the customers, and our dedication to product QC via the development of unique systems that accurately report on the quality of the products. So while we have the capacity to make many different kinds of oligos for the purposes of today's discussion, we wanted to point out that we routinely manufacture oligos for several different conjugation strategies, including those you see here, such as amine chemistries, thiols, alkenes, and azides for click chemistry approaches, as well as cholesterol, dioxygen, and biotin. Now, as you may know, IDT makes more than just primers. In the context of today's discussion, we will cover IDT's capabilities for primer and probe production for qPCR and those types of assays. But IDT also has other capabilities with regards to NGS and CRISPR. So if you have interest in those, please contact us and we'll be happy to discuss those with you. The IDT product evolution is actually now even including the development of enzymes and other reagents that are increasing our footprint in qPCR, gene writing and editing, and next generation sequencing. So now what I'll do is I'll pass it over to Renee, and she'll wrap up the presentation today by telling you a little bit more about the IDT capabilities.
Thanks, Mitch. The 4 pillars of our strategic accounts management ISO 13485 service are quality, flexibility, speed, and personalized support. A typical year is over 90,000 oligos synthesized under ISO 13485 manufacturing. We had 2 ISO 13485 production sites, one in our main facility in Coralville and the other in our Leuven, Belgium location. These 2 sites serve over 500 organizations and produce over 1,000 individual assays or OEM products. Strategic accounts management services at IDT include dedicated support during the manufacturing verification and product validation processes. This is a collaborative process that strives to establish QC metrics and reporting formats that ensure lot-to-lot consistency and functionality. The customer has access to product traceability information about the materials used in the manufacturing instrumentation. The IDT open door policy for on-site process and product auditing facilitates the establishment of these metrics and helps maintain them over time. A very large part of the strategic accounts management ISO 13485 service is providing oligonucleotides for qPCR-based detection methodology. These reagents can be for conventional qPCR as well as digital PCR and include a wide range of fluorophores and quenchers for singleplex and multiplex applications and are often free of IP restrictions. An important aspect of our strategic account management services is working with our customers to ensure long-term growth and satisfaction. To this end, we are open to developing pricing and inventory programs that help mitigate risks associated with the finished product launch and scale-up. We are also happy to establish a supply agreement that can lock in pricing over a defined period of time, define payment terms, and ensure consistency of supply, as well as cover confidentiality and intellectual property. Large-scale synthesis can be done for research applications as well as applications that require ISO 13485. While confidentiality rules are adhered to for all of our projects, confidentiality agreements between IDT and the customer can be established at any point in the relationship. Many of the same services such as mixing, aliquoting, QC aliquots, and kitting that are applied to regular scale synthesis projects can be applied to large-scale projects. To dig a bit deeper into the custom formulation and kitting options IDT offers, you can see here that this can also include custom aliquoting, replicate plating, and a selection of plate types and tubes. Our services can also provide custom labels and packaging, as well as include the packaging of certain third-party reagents. IDT can also provide custom buffers and order integration and drop shipping services. And with that, that is the end of our content for today. Thank you very much.
Thank you, Matthew, Amy, Mitch, and Renee for your informative presentation. We will now start the Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many questions as we have time for. All right, let's get started. Our first question here is for Mitch at IDT. This question asks, how do IDT and Cytiva work together to manage projects?
Well, both companies, offer support throughout the process, all the way from product specification and development through the final product. since both companies are part of Danaher, we have similar cultures, which reduces the barriers that you might experience between companies that aren't in the same organization. So that helps with better transitions and also helps with communication between the companies.
Great, thank you. Our next question here is for Matthew at Cytiva. This question asks, you mentioned Cytiva and IDT reagents being used as part of the lyophilization mix. Please, can you explain more about the composition?
Yeah, sure. So Cytiva has a range of different excipient blends, and these are really critical to the lyophilization process. At the moment, we're developing different blends all the time. We currently have 7 different blends, and these are really tailored to the specific format that we've got for lyo, but also in terms of particularly molecular diagnostics. PCR molecular diagnostics are pretty much our most common assay that we lyophilize, and some of these different blends are really tailored to a LAMP assay, a qPCR assay, or indeed an RT-PCR assay. And the excipients themselves really help maintain the tertiary structure and the sensitivity of the raw materials, particularly when they go in through the different temperatures and pressures of the lyophilization process. And indeed key to particularly the PCR assays that we lyophilize most of the time. The oligos are obviously a very key component of those, along with the primers and probes, and IDT are one of the world leaders in manufacturing those key raw materials. So I think between Cytiva and IDT, it's a really good partnership and differentiate in the market for for customers who want that lyophilization process.
Great, thank you. This next question here is for Renee. Renee, can IDT specifically formulate for a final lyophilized product?
We offer many options of formulations and kitting to supply a product that can be customer specified or specified by Cytiva. We can work directly with Cytiva to produce a product that meets the customer's final specifications. We can drop ship oligos to Cytiva, and we can collaborate directly with Cytiva on your behalf.
Thank you. All right, next question here is again for Mitch. This question asks, are the oligos different between small scale and large scale synthesis?
Well, analytically, they're the same. However, we work with customers all the time to do validation as required by their quality management systems or any other system they might be working with when we do go through scale-up process changes. So it's a fairly routine process for us.
Great, thank you. Next question here is for Matthew again. Why would someone choose a lyophilized cake rather than a bead format?
There are a few subtle differences in terms of the two formats. I think a lot of the times the excipient blends that we use are exactly the same. So from a functionality point of view, there's very little, if any, difference. I think really the two key differentiators are the forecast that the customer wants and also the volume of the reaction that the customer wants lyophilized. So from the cake side of things, in terms of the cake format, it's really tailored towards the small to medium throughput customer that's lyophilizing typically anything from 5 to 100 microliters. The different batch sizes for the cakes typically, and again, kind of referring to a 96-well PCR plate, normally between around 5 and 20,000 reactions in a single batch. The differentiator with the beads is that the bead format is really tailored towards more high throughput customers who are lyophilizing, again, a typical PCR reactions that are between the kind of 5 and 30 microliter range. The typical batch size for beads can be anything as low as 5, but more importantly, anything up to around, even 350,000 beads per production per batch. So again, the excipients are primarily the same, but it's really tailored towards what the customer's demand is and how much volume they're lyophilizing.
Thank you, Matthew. Next question we have here is for Amy. Amy, how does lyophilization extend the life of an assay?
So there's a lot of aspects to extending shelf life, and during lyophilization, when we've added the excipients and frozen and dried the products, we then end up with a solid cake. Now, in a solid, the reagents can't move around, so you can't get any non-specific amplification or any degradation of your enzymes because they are fixed in shape, especially with the excipients in there that will hold the active ingredient or your enzyme in the correct orientation that they need to maintain activity. The other real advantage of lyophilization is that it not only stabilizes your assay for long-term storage, but it also does this at room temperature. And if you're talking about things like point-of-care devices or even just being able to ship around the world and store at room temperature, that's a massive advantage. So you can have a complete assay that's stabilized at room temperature.
Thank you, Amy. Our next question here is for Matthew again. This question asks, have you noticed sustainability becoming a more important reason for companies embarking on lyophilization?
So the lifestable service is offered from Cytiva for the past 10 years, and I think one of the key advantages for the service has certainly been the reduced size, the weight, and the quantity of shipments, and obviously the cost associated with that reduction. But over the years, and certainly from the conversations that we've had with customers and the research that we've done, is that there's been a subtle change in terms of the same questions being asked, but rather than being from a cost point of view, it's generally tailored more now towards sustainability, and that goes throughout the service really. And that's something that obviously from a lyophilization point of view is something that is a really strong differentiator because it reduces the really energy heavy production of dry ice and certainly the polystyrene boxes as well would go with anything that you're shipping around the world on dry ice. So yeah, it's certainly changed throughout the years and tailored now much more towards the sustainability side of things.
Great, thank you. Our next question here is for Amy. Have you lyophilized exosome products?
So yes, we have done we have lyophilized exosomes, predominantly on a small scale in R&D. We have run a few successful experiments. It's not something we've yet put into manufacture, but it's definitely something that we'd be interested in giving a go and working with somebody to develop a procedure for that.
Great. And it looks like we have time for one more question here, and this one is a two-part question, and I'm going to pass it over to Amy as well. So this question asks, typically how long should be anticipated in the development process to lock the LYO recipe, e.g. weeks, months, question mark, and second part here, after locking the recipe, what are typical times for MFG, a small or large batch?
So a lot of this depends on the type of assay that we're locking down. So if we're doing a fairly standard qPCR assay or something similar to what we've done before, and we're using Cytiva excipients, it's often fairly quick to find a lyo program that works. We would often do several small-scale proof of principle runs over the space of, well, our turnaround time for a proof of principle run is expected to be 2 weeks from having all the reagents on site here in Cardiff. And a lot of the time in between pop runs will be dependent on how quickly our customers can test it and what issues we come across en route. So we often can lock a recipe down fairly early in the first run or two, but what we then can do is start tweaking the formulation slightly. Maybe we need to add in more enzyme, maybe we need to add in more excipients, maybe we need to add in more magnesium, things like that. So we work with each of our customers to lock down both the lyo protocol and also the formulation. Once we're happy that that formulation is locked down, again, that can be anything from a couple of weeks to years, depending on the state of time. We will work as fast as the customer while making sure that we don't have any. So we run to 13485 when going to develop it those standards, but we will work with the customer to meet what deadlines we can that they need us to meet. After we locked it down, we would then look to transfer this into manufacture. So I would present all the work we've done to MAC, to QA, manufacture, technical support, and confirm that they're happy with what we've done, and also put together a plan of what we need to move this into manufacture. Now, this validation step can take anything from 3 months upwards. Again, if there are deadlines, there are things we can look at to help with that. And then once it's in manufacture and set up, the typical lead time in manufacture would be 2 to 3 months. But Matt, is there anything you wanted to?
No, I agree with what you said. I think from a lead time, it would certainly be in that 6 to 10 week region. And we ship. I mean, the manufacturing side is here in the UK, but we certainly obviously ship globally as well. So that includes the shipping time to the customer, wherever they are in the world. So yeah.
Well, thank you again, Matthew, Amy, Mitch, and Renee, for your time today and your important research. We would also like to thank LabRoots and our sponsors, Cytiva and IDT, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period, will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Thank you for joining us. Until next time, take care, everyone. Goodbye.